Well, hello 3C. We're going to talk about zero and negative exponents today. So our goal, I know what a zero or negative exponent means, and I can evaluate expressions that contain them. So we're going to go over exactly what an exponent is and what that means to zero and negative exponents. So before we talk too much about negative exponents, please try to remember the exponent laws we learned in the last lesson. They still apply. So we know what a power actually means. 5 to the exponent 3 means that, here, whoop, it's going to appear there. There we go. It means we have 3 5s all multiplied together. So if I take my handy little pen here and I say this actually means 5 times 5 times 5. I get 3 5s and we multiply them together. So what does that mean for something that looks like this? 5 to the negative 3. Does that mean we have negative 3 5s all multiplied together? We can't have negative 3 of something. You just can't. I can't have negative 3 pencils. I can't have negative 3 5s. So this actually makes no sense whatsoever. We can't have negative 3 5s. So we're going to have to try and see if we've got a pattern. And this has nothing to do with the 5 being negative. Nothing at all. The 5 could be negative. We could put a negative in the base. But that has nothing to do with the negative in the exponent. So let's take a look at patterns and see if we can figure it out. So we're going to take a look at the patterns with the two smallest powers that we can do, which is the exponent or the power of 2 and the power of 3. So we're taking a look here. 2 to the exponent 3, 2 times 2 times 2 is 8. 2 to the exponent 2, 2 times 2 is 4. 2 to the exponent 1 means that I just have 1, 2. So that's just 2. And now we got 2 to the 0, which we don't quite understand. I have 0 2's all multiplied together. Does that mean that this is going to be 0? What does this mean? We know it can't be 2 because 2 to the 1 is 2 and 2 to the 0 is something different. So let's have a look and see what our pattern says. I'm going to go backwards this time. Before we looked at it, we'd say 2 to the 1 is 2, and then you times by 2, and you times by 2, and you keep timesing by 2 every time this goes up. But we're following the pattern down. So instead of timesing by 2, we're doing the opposite of that. We're dividing by 2. And then this one, when we go backwards, we're dividing that by 2. So that means that when we go to here, we need to do that again. We need to divide by 2. And that means that 2 divided by 2 is 1. So 2 to the 0 is 1, which is a little odd, but when we say, okay, 2 to the 0 means that I've taken 2 and I've divided it by itself. And any time you divide a number by itself, you get 1. What's that mean about negative 1? Well, let's keep following that pattern backwards. We need to divide by 2. So if I take 1 and I divide by 2, I get a half. And I'm going to deliberately write it as a fraction instead of as a decimal because I think you're going to see something interesting happen here when we go again. We're going to divide by 2 again. What is half of a half? Well, half of a half is a quarter. And then one more step, and if you haven't seen the pattern yet, what's half of a quarter is 1/8. And I want you to take a look here. I'm going to get my little highlighter here and show you that when I have a negative 3, I get 1 over 8. When I had a positive 3, I got 8. I'm going to change the color of my highlighter and say, when I had a negative 2, I got 1 over 4. When I had a positive 2, I got 4. And one last time, when I had a negative 1, I got 1 over 2. When I had a positive 1, I got 2. So it looks like if I have a negative exponent, it's just 1 over the answer I got with the positive exponent. And the reason that is because it's from repeated divisions all the way along. Let's see if that works, because here we're just having everything. Let's see if that works for 3's. So we get 27, 9, and 3 to the 1 is 3, and now 3 to the 0, what is 3 to the 0? Let's take a look at the backwards pattern. What do I have to do to go from 27 to 9? Well, I have to divide by 3. So we're dividing by the base every time, which makes sense because when we went forward, we were multiplying by the base every time. So now we're dividing by the base every time, which means that when I go here, I'm going to do 3 divided by 3, which is 1. Same answer I got for 2 to the 0. And that is because I got this one by dividing by itself. So 3 to the 0 means the base divided by the base. That's what it means. Now we're going to keep going. 1 divided by 3, well, I'm going to write that as the fraction. 1 divided by 3. If I take a third of 3, I get a ninth. If I take a third of ninth, I get 1/27th. And you can see we've got that same pattern that we showed before. I'm going to take my handy dandy highlighter and say, look, when I had -3, I get 1/27. When I had +3, I got 27. And when I had -2, I get 1/9. When I had +2, I get 9. And one more time, when I had -1, I got 1/3. When I had 1, I got just plain 3. So it looks like a negative exponent means I get 1 over the answer I would have got with a positive exponent. So let's summarize this up. The 0 exponent means the base is divided by itself. That's plain and simple. That's what it means. The base has been divided by itself, and it doesn't matter what that base is, it is always 1. A negative exponent mean repeated division. And we end up with the rule that if I have the base to a negative exponent, so let's say base to -n, is the same thing as if I took the base to the positive n, but I put it underneath a 1. So it's 1 over the base to the positive n. So we're going to summarize that up on the next slide here. Here's the 3 rules that we just learned. Rule number 1, and this is for base, and we've got to specify that the base is not 0. Okay? Anything to the exponent 0 other than 0. 0 to the 0 doesn't make any sense. Okay? Base to the 0 equals 1. Next, this one I gave you before. If I have base to a negative exponent, I get the same thing as if I did 1 over the same base to the positive version of that exponent. And we're going to extend it to fractions. Basically what I've done here is I flipped this over. This is the reciprocal. I'm just going to flip back to this screen for a second. When we had this, these things are called the reciprocals of these. Okay? If I take 8, 8 used to be 8 over 1, and I flip it over, I get 1 over 8. Okay, so these are just reciprocals, the flipped over version. So when I do, oh, they went away. Here, let's bring them back. Boop, boop. Okay, if I have a fraction to a negative exponent, that's the same thing as if I just flip that fraction over, the same as I did this, the 1 over thing. This is just simpler because its denominator is 1 in the first place. But I just flip that fraction over and change the exponent to positive. So let's take a look at these. We're just going to fly through these. You might want to put me on pause and write down your answers before I take them up. This says express with a power with a positive exponent. So I don't want an answer here. It does not say evaluate. Evaluate is that magic word that says I want an actual final answer. No, this says express with as a power with a positive exponent. So this is going to be the same thing as if I took 4 to the positive 5, but I put it under a 1. And this one is going to be the same thing as if I took 7 to the positive 3, but I put that over a 1, under a 1. And this one is going to be the same as if I took 8 to the positive 1, which is just 8, and put it underneath a 1. So I've just flipped them over. How about this thing here? This one is kind of interesting. We've got some negative exponents here, which means when you have a negative exponent, it gets shoved down into the denominator and the exponent turns positive. So here's what's going to happen. 24 doesn't have an exponent, so it's going to stay in the numerator. A to the -1 has a negative exponent, so I'm going to shove it to the denominator, and now it's going to be to the positive 1. B squared doesn't have a negative exponent, so it's going to stay in the numerator as b squared. And c to the -3 is going to get shoved down into the denominator, and we're going to turn that to a positive 3. Okay, now down here it says express with a power of 2, 3, 5, or 10 with a negative exponent. Well, we have to take a look at the denominators and see what power they are. Now you can use your calculator if you want. I hope you also use your head here. This 32 can't possibly be 5 or 10, because when I multiply 5 and 10 by anything, I end up with something that ends in a 0 in the case of a 10, or a 0 or 5 in the case of the 5. So the 32 and the 27 either have to be 2 or 3. And I think we've seen 1 over 32 before. I think we've done some questions with that. Maybe not 1 over 32, but we've seen 32. We know that 2 to the exponent 5 is actually 32. So 1 over 32 must equal 2 to the -5. Same thing over here, 27 is probably the 3, since this one was the 2, this one's going to be the 3. And I just happen to know that 3 times 3 is 9, times another 3 is 27. Now if you don't know these, grab your calculator and start multiplying by 3 and see how many of them you take. So 3 to the exponent 3 is actually 27. Which means that for this to be 1 over 27, it must have been 3 to the negative 3. Now here's our one that's a 10. And 10 is really easy. 1,000 is 10 to figure out the exponent to get 10,000, all I have to do is count zeros. 1, 2, 3, 4. So it's 10 to the exponent 4 gives me 10,000. So to get 1 over 10,000 is 10 to the negative 4. Okay, moving right along, what do we got here? Evaluate. Now here's that magic word. Evaluate means I need a final answer. I don't want a power for my final answer. I need a number or a fraction. And in this case it says leave your answer as a fraction. So I'm going to leave it as a fraction. So 2 to the negative 5. We're going to write it first as, I know it's 2 to the positive 5, and then it has to be over 1. But because this word evaluate is here, I have to actually figure out what 2 to the 5th is. And 2 to the 5th is 32. So that's 1 over 32. We're going to be doing a lot with 2's, so you might want to try and commit some of those to memory. It'll make your life a little easier. This one here we know is 1 over 4 squared. Okay, and then it says evaluate as if it were a positive exponent, then take the reciprocal. We actually took the reciprocal first, and now we're going to evaluate the positive exponent, which 4 squared is 16. And lastly, 5 to the negative 3 is going to give me 1 over 5 to the positive 3, and 5 cubed is 125. So this is 1 over 125. And now we get into these fractions that are an actual fraction. And remember, we need to take the reciprocal. That negative exponent means flip it over. But once we flip it over, we make it into a positive exponent. So this becomes 5 over 1 cubed. And we don't need that over 1. Anytime you have a denominator of 1, you can ignore it. So we just have 5 cubed, which we know from being way up here is 125. And this one here, we got to flip over. So that flips over 2 over 1 to the exponent 5. And we've seen 2 to the 5th before. We've seen it a couple of times now. That is going to be 32. And we could have 32 over 1, because 1 to the 5th is just 1. But anything divided by 1 is just itself. So we generally don't even bother writing that. And lastly, this one's a tiny bit more complicated, but we're going to flip it over 2. So 2/3 becomes 3/2 when I flip it over. And this exponent becomes positive. So I get 3/2 squared. Now, what happens when I have a square on a bracket? Well, we talked about that yesterday. We have to square the top and square the bottom. So this actually becomes 9 over 4. That's 3 times 3 over 2 times 2. And our very last example here, express each as an exponent with a base of 2. Well, we had that little list yesterday. So here's that little list again. This only goes up to 2 to the 16th. It's a slightly different list than we had yesterday, but here we can refer to that. So how do I write 4? Well, 4 is 2 squared. So I'm going to take this for part A, and I'm going to write it as 2 squared, but now there's that little 3 on the outside of the brackets. So we want to express as an exponent with a base of 2. So this is 2 to the exponent 6. Now these ones are going to get a little bit different because they've got negative exponents, but only moderately different. What is 16? Let's go over here. 16 is 2 to the 4. So I'm going to write that as 2 to the 4 to the negative 6. Now remember, all of our regular rules applied. So when I have a power of a power, my rule is that I multiply those two things. So I've got 2 to the negative 24. And lastly, C, we need 64. And 64, if we go down here, right here, is 2 to the exponent 6. So we got 2 to the exponent 6. We're going to write 2 to the exponent 6, and then we have negative 3. And we just multiply those because it's a power of a power. So that's 2 to the negative 18. Anything more here? Nope. Looks like we're done. And we're going to leave it at that for this video. Bye-bye.